Okay, so in this lesson we are going to write the slope-intercept form of a linear function given a graph of solutions. So before we write the slope-intercept form of a linear function or a line, we need to figure out what the slope-intercept form is. So slope-intercept form is y equals mx plus b, where the plus b is the y-intercept. Maybe try to write that a little. All right. I can write that a tiny bit better. The slope-intercept, this is where we start, so to speak. And this m is not the x, it's attached to the x. This m and these x and this x are separated. So this m is the slope, also known as our constant rate of change. So the y-intercept is where we start. We're always going to look at where we start first. This will always be where it crosses the y-axis. So I'm going to also put that. We'll put crosses y-axis. Now, so we have this linear function. Remember that this is a line. I don't know why I'm struggling with doing basic things. Okay, this is a line. It goes on infinitely this direction, infinitely that direction. So y equals, and y equals. So our starting point, our y-intercept, this is where it crosses the y-axis. This is where it will cross the x-axis, but we're not interested in that. Where it crosses, where our line crosses the y-axis. So it's at 0, 4. That is our y-intercept. So 0, 4. So right here where it says plus b, we're going to put plus 4. Now let's find some nice integer value points, because remember there's a bunch of these points, but we're just picking the nice ones to help us. So we can tell that we go up to right 3. So up to right 3. That's a positive over a positive, which is a positive. So the m will be a 2/3, and don't forget we need the x. So 2/3 x plus 4. I'm actually going to write that a little bit so it doesn't look so separated. 2/3 x plus 4. We can also write this as 0.66, repeating x plus 4. We can also put the plus 4 first, so 4, and then the plus 2/3 x, or positive 2/3 x. And we can do 4 plus 0.66 x. Now let's prove that at least one of these equations goes with our solutions. So I wouldn't pick 0, 4 again. I mean, you can, but that's really not that helpful, given that we put 4 here. So I'm going to choose 3, 6. No, for y'all, I'm going to choose a -1. So -3, 2, but that's another 3 and a 2. So maybe I'll choose this one, 6, 8, it looks like. 6, 8. So 6, 8 is a solution. That means it has values for our variables that make the equation true. So I'm going to use this one. It doesn't matter which one you use, this one. So y equals 4 plus 2/3 x. Remember the x goes there. I'll put that in a different color. Remember that the x value goes there, and the y value goes there. So it should read 8 equals 4 plus 2/3 times 6. So 8 equals 4. That's going to multiply across. So 2 times 6 is 12. 3 times 1 is 3. And 12 divided by 3. Well, let me write that first. 8 equals 4 plus 12 divided by 3 is 4. So we get 8 equals 8. All right, let's choose a non-solution. So, for instance, we have 6, 8. What if we chose 6, 4 instead? Yeah, let's choose 6, 4. Just, I don't know. 6, 4 should not work. So y equals 4 plus 2/3x. And I am going to remind myself that this is the x, this is the y. So this x goes here, this 4 goes here. So 4 equals 4 plus 2/3 times 6. 4 equals 4. If you use a calculator for this, you will get 4. In case you don't want to write it out like this. And you get 4 equals 8, which is not true. So remember, what we're proving is that these xy's, all these xy's, would go with here, would make this true. If it doesn't make it true, like if this one didn't work, that means 6, 4 wasn't part of the line, wasn't part of the dots, which is correct. Okay, let's do one more. All right, so example number 2. Let's go ahead and write y equals mx plus b. So let's figure out our y-intercept first. Remember, this is y-axis, this is our x-axis. We want to find the y-intercept. This is where it is, which is 0, -2. 0, -2. So y equals, and we'll put -2 instead of +2. Not +2 because it says -2, so -2. Now let's figure out where some nice integer points are. So we go down 3, right 5. So we're finding our slope. To find our slope, we got to go from one point to the next. So down 3, right 5. Down 3, right 5. Down to negative, right to positive. Write that arrow a little nicer. Okay, negative and a positive. So negative over positive is a -3/5. So we'll put -3/5x. And let's put that in decimal form. So -0.6x minus 2. And then we can move this -2 to the front. It becomes -2. We can move this -0.6x right here. So it becomes -0.6x. Then we can do this. Oh, I meant to put -3. It doesn't really matter. I could have put it next, but for fraction first type of thing. Not that it matters. Negative 3 over 5, or so this becomes minus 3 over 5x. And then this one's just the decimal form, negative 2 minus 0.6x. Cool. So remember, these are a bunch of dots. I'm going to choose this one, negative 5, 1, as my solution to test. So I'll write this first one. Y equals negative 3 over 5x minus 2. So this is my x, goes right here. This is my y, goes right there. So 1 equals negative 3 over 5. And then x is negative 5. And then minus 2. All right, so a negative times a negative is a positive. Oh, I forgot to put it over 1. So negative times a negative is a positive. 15. 5 times 1 is 5. $15 over 5 is 3. 3 minus 2 is 1. And 1 does in fact equal 1. Cool. Let's choose one that doesn't work. I don't know, like 2, negative 5. Now let's choose 5, negative 4. 5, negative 4, yeah. I don't know, I just felt like it. So 5, negative 4. So y equals negative 3 over 5x minus 2. This is my x, this is my y, so this goes right here. This goes over here. So negative 4 equals negative 3 over 5. X was 5 minus 2. If you just multiply these in your calculator or in Desmos, a negative, negative times a positive is a negative. And then you'll get, like I said, if you multiply this, a shortcut is, you can just do it all in your head. 3 times 5 is 15. Divided by 5 is 3. So shortcut is negative times a positive is a negative. 3 times 5 is 15. 15 divided by 5 is 3. And negative 3 minus 2 is negative 5, which is not equivalent or equal to negative 4. This is bad. All right, that's it. Thank you.